Hi friends, this video is on somatostatin. I was going through the actions of somatostatin and I was amazed. This somatostatin chap, I don't know what to call it, whether Bollywood hero or protagonist. Those from the Indian subcontinent are aware of the Bollywood movies. In those movies, the protagonist or the hero or the central character is present at multiple places, several places. Frame by frame, you see that hero and he performs different types of actions. He is in the multiple roles. So, somatostatin is somewhat like that. But on the other hand, in all its actions, there is one common theme, and that is all its actions are inhibitory in nature. As we will see in some time, all its actions have that inhibitory connotation like an antagonist in the Bollywood movies. Inhibition, resistance, obstacles. So in that sense, you can call it a villain or an antagonist, whatever you may want to call it. But let's see the actions of the somatostatin. Now the first point is, as I said, multiple types of actions. Somatostatin has endocrine type of action, whereby it is secreted by one type of cell. It is carried by the bloodstream and it acts on the distant target cell. Typical endocrine action. Paracrine type of action means secreted by one cell type and it acts on the neighboring cells without having to go through the bloodstream. So that's paracrine. Neurocrine effect or neurocrine action means the neuronal endings or the axonal endings of the neurons, they release this as a neurotransmitter. In that sense, neurocrine action and even neuroendocrine type of actions. So a variety of actions, multiple roles that is playing everywhere in the body. Let's look at them one by one. First, the endocrine actions. Now this is in the digestive tract where stomach cells, or rather stomach lining has parietal cell, and the parietal cell secretes the HCl. This is responsible for the gastric acidity. But when the gastric pH, or to be precise pyloric pH at the pylorus falls below 2.0, that's too much of an acidic pH, then the D cells at the pylorus will secrete somatostatin. And then this somatostatin will be carried via bloodstream, it will reach the parietal cell and it will inhibit the secretion of HCl so that the further acidic environment can be prevented. So that's the first action, and as I said, an inhibitory action, a negative connotation in that sense. Anyways, now let's look at the next action, the paracrine action. Before I tell you these further actions, let me tell you one thing. Somatostatin is pro-insulin as well as anti-insulin. Yes, it is performing opposite types of actions at the same time. How? Let's see. Now, endocrine pancreas has the islets of Langerhans. It has alpha, beta and delta cells. And it has also got PP cells which secrete pancreatic polypeptide. Now this alpha cell secretes glucagon, which is an anti-insulin hormone in itself. Then beta cells secrete insulin. So glucagon increases the blood glucose, insulin decreases the blood glucose. They are already working at cross purposes. They are already working opposite to each other. Somatostatin comes and it inhibits both these hormones. It inhibits alpha cell, it inhibits beta cell, and therefore it stops the secretion of both the glucagon by alpha cells and insulin by the beta cells. So these warring hormones, they both are inhibited by the somatostatin like a master, like a hero. But again, an inhibitory connotation, a negative connotation to it, inhibitory action. All right. And since it is suppressing the glucagon, you may call it a pro-insulin action. Look, glucagon is anti-insulin. So suppressing it means a pro-insulin effect. But at the same time, it is also suppressing insulin secretion. So an anti-insulin action. And therefore, somatostatin is very often called as pro-insulin as well as anti-insulin. Next, yes, an interesting action now, because here the somatostatin also changes its name. Somatostatin is synthesized by the hypothalamic neurons, and here it is called as GHIH, growth hormone inhibiting hormone. Yes, hypothalamic neurons, their axonal endings will secrete GHIH or somatostatin. And what does it achieve here? It is carried by the portal blood vessels and it reaches the somatotropes in the anterior pituitary gland, and it stops or inhibits the secretion of growth hormone. So again, inhibitory action. As I mentioned, all its actions have common theme, that it inhibits something. Here it inhibits the growth hormone secretion. And mind you, growth hormone is an anti-insulin hormone, isn't it? Growth hormone is a diabetogenic hormone. It is a hyperglycemic hormone, anti-insulin. So by suppressing it, somatostatin will be a pro-insulin hormone or having a pro-insulin effect. So as I mentioned, like a true warrior, it is battling it out everywhere. All right. Next, neuroendocrine, or rather neurocrine action this time. The previous action was neuroendocrine because neuron released it, so neuro, but then it was carried by the bloodstream for a short distance, and that's a feature of the endocrine effect. So therefore I called it neuroendocrine action. Now the neurocrine action. In the cerebral cortex, the neurons secrete somatostatin. You can call it as a neurotransmitter, but better term is co-transmitter, because the GABAergic neurons, they also secrete somatostatin. So you may want to call it co-transmitter. Somatostatin released as a co-transmitter along with who? Along with GABA, which is the most important inhibitory transmitter in the CNS. So again, an inhibitory connotation to its effects. Here in the CNS, it performs the actions of neuromodulation. That is, wherever it is secreted, it will act on the neighboring neurons and will modulate or modify their function. So that's a neurocrine effect of the somatostatin. Finally, let's look at some applied aspect related to somatostatin. I like to call it physio plus plus, something, plus plus or additional information. Now, there are certain tumors which are called as neuroendocrine tumors. And these tumors, they secrete large amounts of various hormones. And these hormones produce a variety of effects collectively called as carcinoid syndrome. Now, an effort is being made to develop somatostatin analogues. Synthetically, somatostatin analogues are being manufactured, and they are being possibly used as a drug in the treatment of carcinoid syndrome. So our protagonist or antagonist, whatever you want to call it, or like a true warrior or true bazigar, it is performing a variety of functions and also has certain use in the treatment of certain disorders.